happening in the driver. You don't have to do it yourself. You just have to decide where you want the servo to go and how long to take.
Yeah, another thing, these are actually controlled with the PST, so you use the keyboard to control it. It goes 1 degree about.
Yep. Well, anyway, you'll have fun, I think, with the new driver. It'll give you some new possibilities.
John, can I outsource my testing responsibility to the young man?
Yeah, sure. Okay. Yeah, I promised his dad I would send it to him first anyway.
All right. Yeah, Kevin, what you're missing is some, sounds like rate control, some speed, some positioning in between the two extremes, which this new driver should do.
Yeah, that'll be great for this. Yeah, thank you.
Yeah, and Johnny Mac, it sounds like he made it easy by also taking it out of the loop source code we might have to otherwise write. Sounds like it's a parameter now.
Well, the nice thing is that with a little bit of planning, you can do nice coordinated moves with multiple servos running at different speeds to get a very organic motion, especially when you have something that looks like a tentacle. I know my friends in the movie business are excited about it.
Well, I just hit the record button, so let's start our meeting like we have an agenda anyway. It is 2 p.m. Pacific. It's later in the UK, earlier in Australia. Everybody welcome to the P2 live forum. Feel free to unmute yourself and you can chat about whatever you want while we wait for a few more people just to load in. Couple things that are coming up. Just today I've replaced the calendar software on our website, but if you go now into the events page, which looks like this, you'll find all the registration links in a more cleaner format to upcoming events that we have. So get a look at that. There's about 7 of them scheduled at this time. So we have a full commitment of things through March relating to the P2. Tomorrow afternoon, 3 p.m. Pacific, John is talking about asynchronous serial. And this is going to be fun, right, John?
Yep.
Like it usually is. So come and join us. All you need is a Propeller board. And if you have other hardware, you'll be able to use it too. And in 2 weeks, we're going to talk about XBs. So if you want to get involved in this, we have these in stock. You can get them anywhere, of course, the XB Series 3. And we have little carrier boards for them, a whole variety of types. And then 2 weeks later, we're going to satisfy every of the 500 comments on the stepper motor thread with the super G code monster object with encoder feedback that drives 50 motors. Right, John?
Yeah, no, we're not. Ken is just saying that, everybody, to wind me up. It's going to be a very simple object.
Step, direction, and maybe something else if we're good.
Well, we'll try some acceleration and deceleration and some basics. Let's learn to walk before we're running races.
If you didn't do anything, you wouldn't give us anything to argue about. So thanks for that, John. Let's see. Oh, yeah, I think I've mentioned this several times. I have a habit of repeating myself. It's what salespeople do. We're about to launch the Parallax Future Innovators Fund, which is going to start out with $5,000 and will allow people the opportunity to send hardware to a student that will make use of it and who may be hindered by what's going on at school or at home or financially or whatever. So just trying to spend your money like it's ours for the benefit of the kids. So keep that in mind, that's coming. And you might notice we have a handful of Brits with us. How nice. So Team Oz is momentarily outnumbered. This is a big deal, right? And I know that while I've been sleeping, I've seen some hardware getting designed and Chip and Baggers have met and yeah, really cleaned up the emulator whole bunch. And there's a bunch of games and this board showed up that I'm buying parts for and that Michael's designing, and it's pretty exciting.
Yeah.
Good job.
Thank you.
I don't know if you guys have any pictures to show today, but that would be fun. Or if you want to talk about this.
Is Chip about?
Yeah, I'm here. I'm here.
Yeah, okay. Do you want to share your screen and show the doc that we've been designing?
Yes. Let's see here.
I'll stop share, Chip.
Yeah, okay. Let me go again.
And do other people just generally have little items of interest to discuss today so we can make sure they get brought up? I have one with video, VGA driving.
I'll do a quick update on the cube.
Oh, the cube. Oh, great. Okay.
And I can do a tiny update on 1/8 scan matrix.
Okay.
You guys can.
You're good to
You
go,
want me to-
Chip.
Okay, so you see this board here. We have 8. We worked with Coley. Let me see if I can scroll down here. And he is designing a nice little. This thing's about 15 inches tall, right? And has maybe a 7-inch display in it.
He's
Are
just
you there,
going to
Graham?
show it.
Yeah.
Yeah, he's there.
Oh man, look at that.
That's just a quick prototype.
That's so cool.
Yeah, so he's going to do this
Talk again,
design.
Coley, so we can see you.
Brilliant.
Yeah, you can see that, can you guys?
Yeah.
Yes.
So
Very neat.
it's sort of, I don't know if you guys in the rest of the world have these quarter arcades.
Yep.
So this is something that Jim's got quite a few of, and I traded him a
Yeah, as you can
Johnny
see,
Mac
Flora
board
background.
for one of those, and that sort of started the conversation about making our own, really. And that's what I've just looked up today.
You just made that up in the last hour or two.
Yep, yep.
Yeah, Jim saw me do it live.
Coley, show that again. I'm going to spotlight the video so we could make
Yeah.
this more
Chip
visible.
needs to
everybody.
stop sharing his screen so
Okay,
the
hold
on.
will work.
Yeah.
Be in trouble without the
Yeah.
co-pilot. Okay, now let's enlarge baggers or Coley.
Coley.
Yeah.
So you can see that. So it's just made out of a foam board for now. Just glued it together, but it's got a. We put the for now. We put the Johnny Mac board inside, and it's just running on the. This is the Parallax 7-inch HDMI screen. But what we've done is designed it around a 7-inch, same LCD, same controller, but with just an AV input, and we just made it a little bit smaller, shorter than the quarter arcade, but wider so that people like me don't have to play it with the fingertips.
If you look at the joystick on the quarter arcade, it's the quarter size of the original arcade joystick, so it's very small.
Yeah.
So for us older people, it's going to be nicer having a bigger full size joystick.
But we're going to fit a joystick, maybe not this size, but this will actually fit in it, and it will have proper arcade size buttons. So
Nice.
easier to play, but not playing it with your fingertips, which you have to do with the quarter arcade version. So yeah, so I plotted out on the plotter today all the plans. I've stuck it to the foam board, cut them out, and glued it together.
Glued it together before
so for
the last 2 hours.
I mean, just for the proof of concept, it works, you know. So what we'll do, Ken, is these will be just cut out of either 3mm or 3mm MDF or 3mm ply. And I thought you could kit them up, parallax, put them on the laser cutter.
Yeah, we have the laser. We don't have our router anymore, but we could laser.
You
these.
don't need a router. And then what there'll be space in the top in the marquee here for some LEDs, and we'll just have an illuminated panel on.
Love to make these.
Yeah.
I need one of them for my desk right now.
Yeah.
Well, so there'll be 8 of these. We'll be making at least 8 just to have connected to Jim's and Chip's code. So there you go. That's me done.
Yes. What we're going to do is connect these boxes up. Let me show the my screen again.
Yep.
So Coley came up with this cool design, and we figured if we could just connect it with one cable without any other wall packs or anything, it would be really nice.
Share
So,
screen.
let's see. Here we go again. So you can see, let's see, let me go to here. Okay, so you can see this. We're going to bring in 12 volts DC on this barrel jack. We'll use like a laptop power supply that has a lot of current. And that 12 volts is going to route to every one of these connectors. We have 8 wires per RJ45 cable. So there's going to be 2 grounds, 2 12 volt signals. That's 4 so far. Then we have the video out, which is NTSC. So it's 1 pin, or PAL. The audio is 1 pin. And then the buttons are 1 pin, and they use that arrangement off to the left. And then the ground loop for the buttons, I don't know if you can see my cursor here, but that's going to come back on a separate wire so it doesn't suffer any V drop because of the current drawing for the display and audio amp over that RJ45. So this has been worked out. This whole thing, this button arrangement works really nicely. So what happens is that cabinet that Coley made is going to have an RJ45 in the back, and it's going to get its power and its audio, video, and button signals from this board here. And this thing can support like eight of these things at one time. And it takes 3 pins to operate each game, which we were talking about last time. And let's see, here we've got some, here's the RJ45 pin out. Here's the schematic for that board we just looked at. It's basically, here are the RJ45 connectors, and then there's just some passives. Michael Mulholland or Von Sarvash, he put a 5 volt switching power supply in here so we can convert 5 down to 12 without any heat, just to feed the P2 edge. We have a reset button.
You mean 12 down to 5, right?
12 down to 5, yeah.
Yeah. And then here, this is the arrangement for the wires. So we're going to use video and ground as a shield, because that's a twisted pair. But at the other end, that's going to be, the ground is going to be used for power. Same with the audio on pin 3 and 6. 3 and 6 make a pair. Oh, excuse me, yeah. 3 and 6 are the 12 volts. 4 and 5 are the audio with the shield. And then the button and return path is on pin 7 and 8. So we don't want to connect that button ground to the power ground. Otherwise, it's going to lift up by a couple 10 millivolts, and it would wreck our scheme here. But this little thing is working quite nicely. I'll show you here. I have a, no, but that's not it. That's the, it's this here that I want. Sharing much screen, I can probably make this a little smaller, right? That's still legible.
Looks good.
Yep, that's fine.
Yeah, so here we have all the 32 button combinations. We just up here put in our resistor values, and we can build all these. Let's see, we're going to do this. We're going to use 2.4K, so we're going to use 1.2Ks to make these 3 resistor values. And we're going to use 150 ohms to make these 3 resistor values. So it's a total of 10 resistors to make 6 different values. So 4 of them are like either in parallel, 2 are in parallel, 2 are in series to get the others. And here's the table for all the resistances for the various combinations. And then here we, these are the readings we expect on the ADC. And here are the thresholds that we discriminate from. And I have this running in a little cog here. I'll run this really quick. Let's see, Control F10. Oh boy, oh, I've got to unplug a board here. Just a second. Oh, I'm getting a funny reading here. Let me see. Oh wait, it's not reading at all. Oh, I came out of the pin. All right, there we go. So I'm going to drag the debug display down here into view. And I don't know if you can see my camera also, but I have these 5 buttons here with these resistors on them. So here's the top button, or the least significant button anyway. Here's the next one, and then here's the last one. But watch this, I can hold these things in any combination, and there's good delineation between button settings.
It's excellent, Chip.
So that's going to, here's all, if I do all 5, wait a minute, 1, 2, 3, 4, there. And I'll let off from one end to the other, and then, anyway, it's going to be sufficient. So one wire, we get 5 buttons out of there.
Excellent.
Okay, now let's see, was there anything else of note on this that we should talk about? I should show you the, I'll show you the games. While we're here, you know that this is what we're going to work on next, is this P2 Edge with 32 megabytes, where we have these 4 8-megabyte chips. But Michael Mulholland realized in order to start working with this, he could just do this. He could put the 16 data pins on a connector, and then we'll just manually jumper over CE and clock. And then we can start doing development for the RAM before we actually have the whole module.
That's cool.
What's the flash you're going to put with that one?
What's the what?
How much flash are you going to put on there?
Oh, there, it's this chip right here. It's 16 megabytes. 16 megabytes. 16. Nice. And then each of these 4 chips are 8 megabytes of RAM.
When can I order them?
Well, I don't know. We're going to have these things ready pretty soon just to start working. I think Michael Mulholland went to bed. It was like getting late for him, and he'd been working all day. But we're going to have a bunch of these. And Ken, you have all these parts on your desk, right? These chips came in.
I do. They're right here.
Okay.
Yeah, they just
there we go.
arrived today. I have 100 of them, but these are different than the ones you're showing. These are 64 megabyte.
No. 64 megabit.
Megabit.
Yeah, when you see the lowercase
divide by 8.
Yeah.
What is that in hex?
It's just divide by 8 to get 8M. It says 8M by 8 right next to it.
Megabytes. Yep.
Yeah, Ken, when you see the MB, but you see a lowercase b, that means bits, not bytes. So you got to divide that by 8 to get how many bytes.
Here's a 64 megabit.
I bet you thought you were getting a bargain there, didn't you?
Yeah, these were 30 cents.
No, are they really?
Oh, they're like 80, but we didn't think they'd arrive.
They're 80 cents, so it's 10 cents a megabyte.
That's good.
What's that an octo?
Okay, back at you, Chip.
Okay, I think that was it. That was all I had. Oh, I want to.
So, Chip, are you going to sell the little test board?
Yeah, we want to make it. Yeah, for anyone that wants it. I mean, we could do these cabinets a lot of ways. I mean, the most economical cabling wise is to use NTSC or PAL because it's just one pin, right? But the video quality is not excellent in that mode. But yeah, we're going to make, he ordered 3 of these boards today. I'm going to get one, and then Coley and Baggers will each get one just for setting this thing up. And they're going to build 8 of these cabinets so that we can demonstrate, 8 video games running in emulation simultaneously. And we found some really supple RJ45 cables that have like 28 gauge stranded conductors. So they're not going to be like these crazy rigid ones that want to rip everything around. So they're going to lay flat on the table. So we can have the, P2 board with the edge in the middle, and then 8 of these boxes coming out of it, all running totally independently. In fact, let me share one. I'll just take my camera here. Let's see. Oh, let me re-download Bagger's emulator here. Hey, Jim.
Yep.
I'm getting the same video on 2 different.
Yeah. The video at the moment is only on pin 8 and 9.
Okay, no problem.
So it's on the first 2 on the AV on pins 8.
Okay, yeah, I saw the same video on both.
Well, it's not the same. It's not the same video. It just
not?
looks like it's the same video. Yeah. If you play, it's reading the same buttons because I've moved the
Oh, okay, gotcha.
Because I've only got two sets of control buttons, which each have 4, but we're now using 5 buttons. So I've put it on the spread it over the 2 and had them all reading the same. So although it looks like there's 2 the same, but if you play which game is it? The Laguna Racer or the Zap 280.
Oh, then
What
it interprets the buttons
happens is
differently.
when you crash, it puts a message on the screen like bam or boom or whatever, and they have a different message on each screen. So that's how you know that they are
Okay,
actually different images. It's just that they're getting the same messages from the joystick at the
I gotcha.
exactly the same time. So they're playing in sync.
Gotcha. Okay, so let's see here. Hold on, let me plug this in all the way. So here's what it comes up with now. So Baggers has all these, the whole little, and he did it in portrait mode, which we need for the screen being in portrait mode. So
Yeah,
if I
'cause
plug
Space
my
Invaders,
button board in, oops, I just started that. Let me hit all 4 buttons. Hold on. All 4 buttons returns to the main menu, right?
Yeah.
Seems to have crashed or something. Let me just hit reset. So let's see. So what would be something no one's seen? Whoops, well, I just hit a button.
That's probably that one. I haven't finished the
Yeah,
IO
yeah.
port for that one
Lunar
yet.
Rescue I didn't see last time.
Yeah, do Lunar Rescue.
Let's see. Oh, okay. The buttons here are not.
It's
There we go.
use the put it on Lunar Rescue and then press the one closest to the P2 edge on pin 16.
There we
There
go.
you
Okay. So there it's running. So we'll have 8 of these running concurrently, completely, on their own hardware and separate states.
On
That
each
looks pretty
cog.
good.
So you'll have all cogs, and each of the cog you can select whatever game you want to play at any point, or reset it and go back to the menu and select another game.
Yeah, it's like having 8 separate
8.
systems that can select umpteen different games and run all completely independently of each other without any awareness of what the others are doing.
Yeah.
Um,
Hey, Chip,
Yeah.
it's probably just as well you didn't continue with the 16 cogs.
I know. I was thinking if we had 16 cogs, you know what we'd be doing?
Yeah, it's making 16.
Yeah, Coley would go broke.
Yeah.
But that 1 megabyte of RAM would be.
Yeah.
There's one other thing I want to show about this is kind of a programming issue. Let's see, get this going again. This is the program that reads those 5 buttons, right? And there is this running on an interrupt and needing to not take much time. I didn't want to have to, normally when we do an ADC, like an instrumentation type ADC measurement, where we want to know what is the signal relative to ground, with respect to the power supply being the reference, we have to take 3 measurements. We have to measure the ground calibration. We have to set the ADC. We have to connect the ADC internally to ground. Doesn't have anything to do with the pin. We measure ground, then we connect it to VDD or not VDD, but VIO, which is 3.3 volts. We measure that, and then we measure the signal of interest. And then what we have is a first order equation like, AX plus B, where you have a scale factor and an offset. And this, in order to solve your final reading, you have to do a division, which is a pain because division would require the Cordic if we're going to do that in hardware. And the Cordic is, that means that you're going to be there in the interrupt routine for a long time. And we didn't want to do that. So I was thinking, how can we get around this whole issue of needing to do this divide. And I realized that what if we just do this? We start off with some arbitrary value, which I actually came up with the formula for. It's pretty simple. And we measure ground, and then we switch and we measure power. I mean, I should say the power supply voltage, right? We measure ground voltage and the supply voltage, and that would give us our frame. But then what if we just adjust how long the conversion takes, right? Because it's all in terms of clock cycles, and the more clock cycles the conversion takes, the more bits you're gonna get, the higher the numbers you're gonna get. So what this thing does now is it actually like keeps bumping the conversion time up and down until it gets a spread of 3,300 between ground measurement and the voltage supply measurement, right? So that gets rid of the scale factor, because now we're in millivolts. So all we got to do then is read the pin and subtract off the ground measurement, and we have millivolts. So it's totally adaptive. The thing is, though, you can only do this for like one pin at a time, because every pin's different enough that it wouldn't work. But it gets us around needing the division, and we get our reading straight back in millivolts just with an offset. And so up here is where I set up the pin to do the ADC. I configure it here for the ADC, and then I set the interrupt vector, and I set the sensitivity for the interrupt, and then enable the interrupt, so that every time the ADC, it's not even using really the ADC mode, it's using the count highs mode, which just over a period of some number of clocks you give it, it counts how many times the signal was high, which is the bit stream coming out of the ADC, right? So, and here's the funny thing, I found out, and this is something it was the design, but I didn't really realize it. If my target is scale, the number of clocks that it's roughly going to require in order to get that spread of scale between ground and power, or between ground and V supply, is scale times 1.5. Real simple. So we started off there, and then when it's in the routine, every time it does a set of conversions where it measures, you know, ground, V supply, and pin, it checks to see, are we above or below the target? So it does a subtract to get the difference, and then it compares what's left to the target. Are we at like 3,300? If we're not, then it bumps that sample period up or down by 1, so that next time through, it's going to hit it, you know, where it needs to be. And I don't know if you guys know, but if you've ever done any interrupt programming, we have this thing, you know, normally in processors, you have a return from interrupt, right? Which goes back, and then when the interrupt re-triggers, you're back at the beginning of your interrupt service routine, unless you repointed it. But here we have this thing called resume from interrupt, which does a return from interrupt, but next time the interrupt occurs, it goes right back to the next instruction. So you can do interrupts. Your interrupt can just be a few instructions, and then it breaks, goes back to the mainline code. Next time the event occurs, comes in, and then goes back to the mainline code. So we're fitting like, you know, 4 clocks worth of important instructions in on each of these interrupts. So we don't have to like figure out what state we're in, because the program counter is holding the state. You know, where it left off on the interrupt comes right back. So what we have here is this first one. Let's say this, we start off on this last one, right? We say, we do 2 phases for a reading. Once we redirect where the ADC is pointed, be it ground, V supply, or input, we do a rest cycle to allow the internal circuitry to kind of settle into the new stasis for whatever that new voltage level is. Because if you switch it too abruptly, you've got a lot of leftover bias in that feedback circuit and the whole thing. You want that to kind of wash out so it doesn't affect your reading. So when we are set up here, we're pointed to GIO, we do a rest period, right? So the interrupt occurs because the count for the count highs timed out. We got a reading, but we ignore that reading and we just acknowledge the pin and then go back to the main code. Then the next time the interrupt occurs, we read the pin, and then we, let's see, write pin. See, what is this thing doing? Connect. Oh, and then we change the mux to the ADC, so it's now pointing to the next signal we want to look at, which in this case is the pin. And then we do, now we're pointing to the pin, so we do a rest cycle. Then we grab the pin value in the level pin, and then we point the ADC to VIO, which is the next thing we want to do. Then we do a rest period, and then here we actually do our math aside from also redirecting. Here we do, when we come back in, we grab the VIO, then we redirect to GIO, and then here we do the math where we adjust the time frame up or down by 1 in order to get the scale that we want, and then we take the offset, the ground offset from our pin level, and then we have our actual sample, and then we scan through the thresholds. This needs to be optimized so it doesn't take a loop, but we scan through the thresholds until we find the point at which we go, okay, it's got to be this button combination. And then we, at this point, we do we redirect iJump3 back to 80 all the way up to here. So that on the next interrupt, it's going to come and land right here again. And the cycle repeats. So if I go to the top here, we have our scale set at 5,000, but we can make it 3,300 for millivolts, right? So then when I run this, you can see here on V1, it's doing 5,056 or so clocks to take that measurement in order to get a 3,300 spread between the ground and V supply readings. And then V2 is the sample that we took when we were pointing to the pin with the ground offset measurement subtracted. And we get, that's straight millivolts right there in V2. So it just takes a little bit of code to do this, but we get to avoid having to do a divide, which would have been, time consuming.
Well, I'm really interested in understanding this at a deeper level because it sounds like there are about 2 or 3 different tricks or lessons in it. But I don't think by reviewing everything you just explained that I'll get it just with that. So
I was watching your face for visual cues as I explained this to see if, are you using you, like, do they understand? You seem to be understanding. What I'll do is
yeah, I get a little bit of it, but I think a couple sketches would probably get me 90% of the way there.
Okay, yeah, I'll post this with the latest picture into that one button many pins thread or whatever it's called. So any questions about this thing?
Are we going to have a quick Byte Smart Pin edition?
Yes. Yes. Ken wants to do this. He's ordered these resistor sets so that you can, with some push buttons, so you can, anybody can recreate this on their Johnny Mac board.
Nice.
In this case, though, I'll only be able to work with what Chip provides. So if he provides a good schematic and explanation, that'll just become the quick Byte. And there'll be a little bag of parts too, if somebody wants to duplicate it.
I have a question about the SPI RAM in terms of positioning versus the HyperRAM. So I've been planning on using HyperRAM by default. What's the top 1 or 2 questions I would ask to decide whether or not to wait to use the SPI or to go ahead and work with the HyperRAM?
Well, Roger in Australia, he's done, I think that or New Zealand, I think he's in Australia. He's been working on a HyperRAM driver, which I think is almost done. And he's gone through a lot of extensive work to make it really fast and everything. But there are a lot of ambiguities about that chip that you kind of have to, you can't, there are some things that you can't quite infer from the data sheet. And it was kind of complicated. And then it has this one control signal that you have to be asserting at the data rate in order to control writes and reads and other things. These chips are just a lot simpler. And these are just standard, quad SPI parts. They only take, aside from the data pins, you can tie all of their CSs and their clocks together. And it's a very simple protocol. So I just figured for what we're doing here, this is probably less headache than the HyperRAM. So it's just, and if you look at this this little board we made up here, the data paths take up both of the connectors, but we're just gonna have little wire jumpers where you can jumper to what other pin you want on some other header to control CE and clock.
I have another comment on hardware selection, but I'll wait until my turn in the queue.
You had a comment on what?
Well, I'll wrap it up with the cube update. I have a question regarding how to assemble dense parts that don't require people to build their own PCBs or do a lot of soldering. It's basically like a strategic question about.
Oh, yeah. Okay. All right. I'll stop sharing. I think I'm done unless anyone has any more question about any of this. Oh, one thing. Oh, go ahead. To recap, here's the pins. These are the like signals that come off of the P2 that go to those 8 jacks to control the 8 arcade machines. The first column is the video signals, then the audio signals, and the button signals. And we did them all sequentially just to demonstrate that, like if we put all 8 audios on one set of 8 pins and all videos on another, people might be inclined to look at that and think, oh, well, there must be something special about those 8 pins. So, 3 is a horrid number when it comes to base 2 everything, right? So we can distribute these in sets of 3, just linearly like this, and it works. Okay.
Okay, so before we move on, just a quick look at some of the things that were brought up of interest. VGA, and then the cube/hub75, and then real-time clock question, and then if we want to also, Kevin, if he wants to bring his servo question back, we can deal with that. Maybe before we go to Jonathan and talk about cube, I can present my VGA question. That's all right. So a little background on what I'm trying to do. I am trying to find a VGA example that I can use as a quick byte. And I started out with chips driver, which was a little bit too minimal, didn't have all the constants in it and friendliness I was looking for. It was just really a test driver. And so I was pointed to the Roglo driver, and I'm going to share my screen. Pardon me while I'm working from a laptop, so it's a little bit tricky to do all this stuff effectively. Okay, so I think now you see my whole screen, right? So I downloaded this code, and I just want to know if people could point me more in the right direction of what's what, so we can make what is what, the correct what. And there are these 3 drivers. I believe these are kind of the favored community drivers for VGA. And if anyone knows, and they could tell me, that would be great. But when I go to run the code, by the way, this is Chip's demo here, and then underneath it here I have the one that is Roglo's, and it has some compilation issues with it. And I'm wondering if anyone has a working version of this that I could start from. So it seems to be missing parentheses and things, and then I have some constants that appear with the same name. So I'm not really sure where to go with this. This is a flex prop thing. Okay, that might explain it. So I might need to recast the question then, if somebody can point me to the most complete VGA driver that runs on Spin 2 on Windows.
Yep. Ken, are you after color VGA or are you after text VGA?
I'm after text, just use it like a terminal's display and output device. Basic stuff.
Okay, then I should be there in a few days. I've got an LCD working now. If you can see my screen, let me get my camera. Where's
there? That, yeah.
Okay, yeah, that's a little 4-inch screen. It's actually scrolling. Now there's a bug in the chip inside the LCD and I cannot read the screen back. So I'm having to just scroll, as you said, it scrolls down the end. So I've got to that blue line is actually debug information. It clears the line, the current line and the line below it every time it moves down a line. So see it, notice it goes back up the top. But I've actually got scrolling working if I can read it back. Now, the difference with VGA is that we're controlling the bitmap. So we've got more control over it. So I'm very close to, because I've got the LCD running on now, my next task is to get VGA running the same.
So will this driver then have
some,
that'd be great actually. Will this driver have some control over cursor positioning, color, background, and then resolution, choice of resolution?
Yes, at the moment, this driver here is totally soft controlled. So the number of bits on a line, it is using a fixed font of 8x8 at the moment. I haven't implemented color from the point of view of the ANSI set, but I do have XY coordinates working.
Great.
Perhaps I should shoot this across to you.
Yeah, I'm ready to try it. I even try it right now. But yep.
Ken, I gave you guys a driver, and I think they already added it in for a little LCD display, and it does text and graphics.
Okay, is that in our GitHub then?
It is. I can show you this display.
Yeah.
Let me turn on my camera here real quick.
And then Ray, too, on your SD card, I'll come back to you and have some questions on that. Oh, I see, Greg.
Let me get that in front of the camera there. I got my green screen's kind of messing it all up. Let me turn off the green screen. Hang on a second.
And that one is in our OBEX, I believe. And then what is the interface to the display?
It's just it's a SPI, and it's ILI 9431, I think, or something like that. Chip. You can get them on eBay for about $8, $9.
Okay, are these just I was posting that thing under the forum, but are you talking about displays?
Yeah.
Okay. So this is like a color display.
Yeah, I'll get a better picture of it here. I need to figure out how to stop the green screen on this and
well, that's good too, Greg. I'll get a look at that and go find the object, run it, and get the hardware and present it more completely. And I'll do the same with the flex prop driver that I found. I probably should have read the whole forum thread, but it was pretty long. And then work with Ray to present his driver.
Yeah, Johnny Mac helped out a lot because I had this driver. You guys had this driver for the P1, and I converted it. And Johnny Mac kind of helped quite a bit. There we go. I think.
Greg, did you manage to get reading back from the screen working?
I don't think the original driver had that option in it.
Okay, so you don't have scrolling.
But this particular, I think we got it now. Let me try this again and see if it comes up without. Yeah, there we go. So
nice little display.
And
cheap
then
too.
On the back side, it's got an SD card reader, and just about I think it's a 14-pin header there for.
Yeah. Yeah.
Yep, he's got the same one.
Yeah. When you order those, often they have two varieties, one with a resistive touch and one without.
Yeah, this one does have a touchscreen on it. And I believe in the object that I gave you, I think I converted it's a XT20 something, I think. I converted that driver as well.
Yep. I haven't tried the touch interface, but it's got touch on it. Mine's a little 4-inch, but I know they make about 3.5-inch and a couple of others.
Yeah,
and they're all about $10 or $12.
Yeah, this one's a 3.2. I've got a 4-inch that I bought for $4 off Amazon. I thought it was the same thing, but when I got it, it definitely was not what they said it was, and it's got some oddball chip on it.
Mine's got an ST7796. But I can get scrolling working in the hardware if I have 320 wide and 480 high. But I want landscape mode so I can get at least 60 characters in an 8x8, or I can get 80 characters on a line in a 5x7 picture.
Okay, well, thanks a lot, guys. This answers my question. Greg, can you post a link to the functional version you bought off Amazon?
Let me, I don't know if I got this off Amazon or eBay. Let me
Okay.
look back at my history real quick here and I'll see if I can find it.
Yeah, I
for you.
just want to go where you guys are going and present what's working to others.
Yeah.
Find the hardware.
Ken,
Yeah.
what's the specs for the VGA? Does it need to be like 640, 480, or does it have to be?
Oh, it could be anything.
Yeah, because the ones that I did, I had the HDMI driver, I had the VGA driver, and then we ended up going with the one pin on the composite. If you need anything on that change, just let me know.
Yeah, I'll be coming after a composite one next.
Yep.
I mean,
Yep.
sort of the order of priorities I had in mind was VGA, and then now Greg has shared this other display with SPI interface, and then composite fits in there and HDMI, and I'm not really seeing the super driver solution, so we'll present them all individually, which is fine.
Yep. Okay.
Unless that's not the right thing to do. But I think the idea I have in mind is somebody has a display and they want to drive it. So
yeah, I think the driver that I have, it has a go to XY function, has a draw pixel function, and then it also has a draw text function. And I think it has like a draw circle and a draw square function.
Very nice.
Did you take the P1 driver or the P2 driver that I did, or did you write your own?
I took the P1 driver and just reworked it to run on the P2.
Is that the one with the clock, draws a clock?
Yeah, I think the original demo drew a clock, but I don't think I ported that over. I just ported over the basic stuff, but I think it is the one that drew the clock.
Yeah, that's the one I wrote. So yeah, so we've got the same base code.
Yeah.
But I've spent days trying to get scrolling working. I can get it working in portrait. I can't get it working in landscape, and searching the web looks like there's a problem in reading back the data, and that's what I've had, and I had to do a reset, and I gave up this morning. And so I've scrolled the screen. It has to go back to the top. I can't avoid that.
All right, Ken, there's your link. I just posted
great.
it.
Thank you. Okay, I'll get a few of those then, and we'll include that. Looks like Roger's driver does everything, but it's designed for flex prop, right? Which is fine, but it does DVI, HD, VGA component, and composite. So I'll restart my effort. Okay, that's all for my sideshow. So we could talk about the Cube and Hub 75 now.
Okay, so I'll switch my camera here. OBS virtual camera is really handy. So let me turn this off. All right, you can see my cluttered workspace. I'm just showing the proportion of things, and I'm going to talk about what I've done recently and what my next challenge is. This is the power brick I'm using. It's just a LiPo battery. It's a 50C LiPo battery, so it'll put out a lot of current. And you can see I was trying to wire my benchtop supply up with that basically with the terminal block, and my benchtop supply doesn't have enough current to let me do an adequate test of the full cube. So I'm going to have to test with a LiPo. That's the only thing I have that'll push that much current. So that's what I'm working on next, is just going down to 1 or 2 panels in the chain and doing some current measurements with all the LEDs on at full brightness, just to see what the real requirements are. Because if we have to support 25 watts per panel by 6 panels, that's a lot, and I don't really believe that we need to do that. So I'm going to test it and see.
If
but
you can
could
get a LiPo to power a quadcopter, I bet it could do that.
Yeah, I think the LiPo can do it. I guess what I'm wondering, so one of the challenges we have is that since we don't have a 5-volt standard coming right out of the LiPo, you can see, do I have it in camera there? I don't see it. Let me see if I can put it in view. That would require that I find it again. I have a 10 amp, like automotive grade voltage regulator. Oh, here it is. Here, I'll stick this in camera view. So that only gives us 10 amps. And I need to make sure it'll support a variable voltage. It may be 12 or 24 only. I'll just double check that. But I also have these tiny little 3 amp regulators that I thought about using. But to do this, I'll have to do some custom assembly. And what I'm trying to do, really what I would like to do is have a kit where you can buy a P2 edge and some bits, buy the Iron Sheep Hub 75 adapter, and wire it up. I want this to be an intermediate level kit. I'm trying to keep it from becoming too demanding for users. Now you can see the size of the 3 amp voltage regulator compared to the 10 amp one, and the size difference is striking. But this would require some custom wiring harnesses and maybe some PCB assembly and things like that. So my current challenge is really to fit everything in and power it. So you can see this firewall plate. The white plates on the back of each face are there to protect the driver boards. And with that, it's relatively safe to put things in here inside the box. Well, if you look at
that big power module you have is not exemplary of what you can achieve on your own. If you were to build some switcher circuit, you could get pretty high efficiency, area and volume wise. But the module there is,
this is ruggedized and all weather and that kind of stuff.
It's probably potted and everything, and it's kind of its own heat sink. But
I could put one of these on each board. I just don't want to require people to have to do that. This is only 3 amps, right? The boards on the spec sheet say 25 watts, which is 5 amps, 5 volts, right? So I'm hoping this is enough, which is what I'm going to test with just to see. But still, if we have a power supply that'll give us 150 watts off of a 7.4 volt supply at high current, that's what I need. That's what I'm looking for. Because this is not ideal. And of course, this is not ideal. Something else that we can take off the shelf and put in this box would work way better than either of these.
Jonathan, a note just to help adapt your thinking. If we get to a point where you've achieved the brightness you want, the driver itself can threshold limit the brightness that we drive all of the pixels. And so we really can control the maximum power draw per board.
I do believe that the brightness capability of these boards is far in excess of blinking lights, right? Correct. It's quite bright. And I haven't really shown everybody the board assembly so far. So here's what I'm going to do. I'm going to, well, these are wired in. Maybe I can stuff this in there. I wanted to show you, well, nope, that's too big. You see, we have limited space.
Part of the reason that they're so bright is that they're designed to be parts of large panels viewed from a distance outside.
Yeah.
And so they're super bright for that.
So if we could safely limit, the threshold, that would be great. So this is one side, but you see that the magnetic glass works, and the finish of the cube shape is actually pretty nice, notwithstanding the scuffing that's come from my workbench. But it's quite together. It's quite one piece when it's assembled. The trick then is, how do we get this and 2 or 3 other pieces, including maybe some resettable fuses, maybe some inertial sensors and things like that in here. And that's the next challenge. So that's basically it. I'll take any questions and ideas.
I think the best option is going to be making a custom board that you can plug the edge and the.
We're losing your audio, Ray.
Yeah, we lost you.
Is it okay?
Suggesting
Can you hear me
custom
now?
board. Yeah, you're
Yes,
back.
thank you.
Okay. I think you're going to have to make a custom board that an edge can plug into with Steven's circuitry and the power circuitry on it in order for it to fit. And that,
Yeah.
and also be easy for anyone to do, right?
That's the catch. If we want to make it off the shelf and easy for somebody to buy as a kit and just do, like incentivize people to build, then we're missing the glue layer to put it all together.
Could that board be all through hole, Jonathan?
I think it could. So let me turn off my camera again so you can see the part.
Because we could volunteer Michael to do the board.
So if you look at I've got just the P2 edge adapter there. I've got the 90 degree and the straight through just to show size. And I thought about wiring direct there, but it still doesn't solve I mean, if we do that, we could get more than one channel, but we can't get basically the P2 prototyping header format in there very easily. And that's part of the catch here. It's really nice to be able to snap a 2x12 on something, but it has a certain footprint that doesn't want to fit into a cube, obviously. So that's another question I was going to bring to you guys, Gracie and crew, is this a time for us to be talking about what the small, like cartridge edge format of boards that people could use? Like, do we want to have a community standard of some kind, or just think like the prop plugs format, but maybe on a bigger header that you could like stack things in like a magazine? Is that something we should talk about, or should we wait on that?
I had a thought too, Jonathan. The board that we have, Ken, what do you call it? The micro edge?
Yeah, I think you're thinking of the microbit adapter. I'm going to go ahead and mute some people.
No, I'm thinking about the edge adapter that's small, not the Johnny Mac, but the tiny one.
The mini breakout board, and our website is having trouble right now because we're running tests on it because the various scripts that are in WordPress have constipated it terribly.
Yeah, the mini breakout.
That's this.
Correct. Well, no, there's another one of those that has the headers. That's all pre.
Oh yeah, the mini breadboard version.
Right.
The mini
breadboard version. We need the connectors to be rotated 180 to actually, so we can fit the twin boards or the boards through right angle connectors parallel to the edge card. Right now, with the connectors on the board, they stick out like an L, something like this. And if we actually rotate those connectors and put 180s, now our boards go like this.
So if we just had a 90 degree header pin set that we could use on that board unsoldered, that might get us there for that cartridge format.
It doesn't, because what happens is your boards look like this then. And so you need this connector set rotated so they come up next to each other. Does that make sense?
Yeah, but I'm saying if you could pick the top or the bottom to use on either side, maybe. One side use the top, one side use the bottom. I'm just thinking out loud here. But if you could do it, imagine not twisting it and just folding it up. Which side would the pins have to be on to allow for that?
Yeah, by putting right angles on, we could do another layout of the board that would accept right angle headers, but then the pins are incorrect for the orientation that we want. So we actually have to move signals around in those headers, which means rotating the headers.
Yeah, I'm not seeing the twist problem yet, but I'm sure I'm just not, it's a 3D problem. So
it is, and that's why I've been thinking about it. And so doing another turn of that board that supports right angles and then parallel mounting would be a pretty small thing. That gives you 2 of the 16 IO connectors.
Which would be enough for a 1x6 Hub 75 adapter. Now we don't know for sure. I mean, proof in the pudding that a 1x6 is going to be that desirable. We know it's going to be simple enough for the base kit, and I think we should make sure that we can do that. In terms of refresh rate, we can do the math on it, but we don't know exactly how it's going to feel when somebody looks at it, you know, with a 60 frame per second video stream. So
yeah, I think it's going to be easy to achieve 60 frame. If you want higher, then we probably have to go twin 1x3s.
you think we can do 60 frames per second buffering six boards on one channel?
I think we'll be able to.
Okay.
I got to go back.
We shouldn't complicate it then.
It worked out that way.
Yeah, we should. I think then if we were able to get 2 of the 2x12 header sets, we could do one for the Hub 75 adapter. Then we could do another. Well, we wouldn't be able to hook up like the inertial sensor and a Wi-Fi plug, you know, prop plug and that kind of stuff. We wouldn't have enough room for all that.
That board supports the Wi-Fi on the single connector, doesn't it?
Does it?
And would you know?
It does, yeah.
Okay.
Okay, so
that means you could put the IMU on the other 16.
then we should probably think about that. Either a different kit, like a different bill of materials than that mini breadboard adapter that lets us. Well, no, you're saying that we can't do that without a PCB realignment.
Right.
Open question. How do we solve this?
Well, Ken, if we can get Michael to lay this out, right? What he needs is an edge. What you're talking about is an edge adapter that has ribbon cables coming out in orientations that are friendly to this whole cube thing.
Or you could do right angles and mountain. I wasn't thinking ribbon, but you could do ribbon.
Stephen, is this what you meant? This sort of...
Yes.
There we go.
Uh-oh, he'll build it.
What about a 2-socket backplane where one socket is for your edge and the other socket is an I/O board?
And the I/O has to move those pin headers out there. That's what you're thinking?
Well, the I/O board would be custom. You could design the I/O board any way you wanted to. It would just plug into the socket just like the edge does.
No, yeah. I think we were trying to do it with existing parts for sale without trying to engineer too much. But that's certainly a thought. I think the only thing, was that Graham that just showed us the drawing? Yeah, I think the only thing different is I'd put the Hub 75 connector as external instead of towards this thing, towards the edge card, but yes. Because the boards actually connect through the backside, not through the front like you have it. The Hub 75 boards.
Right, okay.
Yeah.
That'd be pretty easy to spin up though, that, surely.
Yeah. Yeah, and so basically that just means connectors reoriented on the adapter, on the mini breakup board.
Plus a way to get to
that'd
the
be
IMU.
That'd be a re-layout of that. The click and the IMU is a little bit thick, so that's going to take up space. But I think once we sell the orientation, that might fit. Jonathan, what do you think?
Yeah. So what I wanted to do really is and I wish somebody could tell me where I put my calipers, but I don't have enough cameras around for that. I wanted to give an idea of the shape. So if you look at the original P2 board, that basically represents the safe design size for what we put in a cube. Now there's a little bit of extra play in there.
Yep.
These subframe plates I put in were meant to sequester the wiring against the walls, but it just didn't work well. So I gave up on that. These are trash. But this the space in here is pretty open apart from the Hub 75 and power connectors, and this is a really good reference for that.
Okay.
I think most of the people here have one.
So we're looking at a cube that edge diameter.
Yes.
Okay.
Looking to fit a P2 edge into that cube with 2 accessories, P2 or the Hub 75 adapter and a version, either MicroClick or some other type of inertial sensor.
Mm-hmm.
And of course, programming.
Mm-hmm. Which would be the Wi-Fi if you can.
Yes. Now I don't know if this is really like a special request. I mean, I was debating whether or not I wanted to ask for something that we could do that was just for this, or if this was a more general question, which is why I was talking about maybe a secondary pin header format that's
Well,
stacked.
Jonathan, if you can specify something, we can have Michael lay it out. It would take him like a day or so.
Okay, and do you think that it's worth you guys just fabbing and selling it as part of this kit? Does it make sense for you guys?
Sure.
Yeah.
Well, even to facilitate one of these is important to us. So if people want to
Okay.
make more, that'd be great.
Yeah, this is a showcase of the P2, and we've committed. I've got the panels coming, and we've committed to this. So, like Chip said, we can have Michael make the board, or Stephen can. Someone needs to identify the shape of it, and then we'll get it
Okay.
started. Yeah.
So maybe I'll try to sketch up some notes and send you guys just to capture what we talked about here. I do want to do one quick refresh of what the 3D print does for everyone, because it may not be obvious here. The video I showed before was really quick. This is a magnetic connector. It's only on the top. It works really well. But every other part of this, the connectors, the plates, they're all printable without supports of any kind. If you have a 3D printer that will print at a 45 degree without overhang without any supports, which most will, and you calibrate, the dimensionality of it, make sure you're printing accurate parts, then you can print all these parts and you can assemble these LED panels to these frames. There's a little bit of gluing, but it's better than doing the supports, just some light CA glue. And then everything basically snaps together. These don't know if you can see them. Inside, right there on that edge where my thumb is, that's a snap-in connector. And it snaps in at a 45 degree angle in the corner. And this thing hasn't come apart one bit since I put it together. So I'm going to share those now. Since we're talking about the next step, it's time to share the 3D files. So I'll put those in the forum soon.
Wow. Yeah, the least we could do is help get the hardware together. This is amazing.
Well, you're lucky my 3D printer spends more time apart than it does together, and I've yet to get it to print anything successfully since I got it.
Oh, wow. Sorry to hear.
Jonathan, one idea for you to look into, you may have already. One thing that's taking up room there is your wiring. Have you thought of PCB backing there?
I have. What I'm probably going to do is, since these panels come with wiring of their own, there's plenty of appropriate gauge wiring in there to reuse to make a custom wiring harness. And as long as it doesn't seem that we have to dual power this, I'm considering just laying this out like with tape or something, and then making it just a basic wiring harness diagram for people to know what lengths to cut and how to do safe, like high current wiring, and make it so that there's just a wiring harness that lays around the cube, kind of like a fabric. It's easier to work with than that big jumble of wires, because obviously that's way too much wire. But I think a PCB might be more complicated than I would want to put in there for that, but I think a custom wiring harness would certainly help.
Well, you may end up having to do it wiring, but the concept of like say one side where your wire comes in and plugs into the board. If you had a PCB the size of the back there where your white plastic is, and the back side of the PC board plugged into that, and brought the traces out to the edge to join with the concurrent sides, you'd have a lot of room left on each PCB. One could house the propeller, one could house your battery mechanism, another for your sensors, and so on and so forth.
I think that you're onto something there, but what I'm thinking of is taking those insulator plates, and since we're not using the interior subframe that I was trying, just extending a little surface on this in some places so that we have a direct place to mount things. Just using these plates, because they snap in. The edge, if you see there's some little bumps on the edge, that just snaps into one side of the joint. And it snaps in place pretty well. If we put some risers on there that we can use to mount whatever PCBs on we want, I think that'll be better. But that's, hello? It'll be a trick, because if you look inside the cube, every one of these faces has to have a particular orientation for the cables. So the bottom, in order to simplify the geometry mapping, the bottom rolls up to the first side face, and then the fourth side face rolls up to the top face in terms of the layout. So we have a consistent driver layout when we do the programming. And what that means is even just for the sides that go around, it creates intrusions into the inside space, which make it hard to do anything but the minimal cube that fits inside it safely. So we would have the same challenge of doing the PCB design for them, because they would all have to be somewhat custom and may have 2 or 3 different variations if we were going to use those for connecting things. But I may be misunderstanding your idea, but I'm definitely interested in more food for thought if you have something there that I'm missing.
What I have, I don't know, but on the edges where the wires connect, like you said, the bottom comes up to the first side. If it was just like the headers on the P2 eval there, they're on the corner, they're sticking up. If you had a right angle header on the first upright side, it would just plug into it. So you'd have a PCB square inside that square being held together by the pins that are carrying your signals.
I'm going to prototype live. We'll do it live. Let's see what happens here. So here's one side. Here's the P2 edge. We could go above these caps. If we had, so let's get the 90-degree P2 edge adapter in here. Am I doing it backwards? No, it's just friction. So I'm not sure if there's room on. Maybe if we.
Maybe you just need a P2 edge on every panel.
Yeah.
Well, I mean, if all the other stuff were on the PCBs that are going to go around it, the edge could actually stick out. It wouldn't have to lay flat.
Okay, so let's do something like this then. So that would be what part of a PCB. Now it could go in this place between the connectors, or it could go on a side. Better on the side because we have cables going around on each side.
And the battery.
And the battery, assuming we can do with one, can fit on the other side. So with the setup we have here, we're able to kind of fit the battery in where it'll fit, and we can put foam and other things in there as long as they don't interfere with the cooling and convection. I'm not worried about fitting the stuff in there in this size. It's just whenever you use the mini, and I lost my mini breadboard. So when you put all these together, like on the mini breadboard, and then you try to put, I mean, you can see that we're running out of space pretty quickly to fit things. So assuming we were able to fold them up, we can fit them folded up. It's not a problem. But I am interested in finding better ways to use these back faces to make mounting better. But I feel like we need to figure out the actual powering and connections before we try to mount them in for now. It's a learning process, and you know, there's a lot of things that I've tried to try to make it easy to build that didn't work, and obviously we're shelved.
I think it would be good to put you, Jonathan, and whoever else wants to join, and Michael, Stephen, and Chip into a Zoom where you could share everything on your desk and let Michael get a good look at it. And we could probably make a lot of progress.
I think that would be great.
Seem like a good approach?
I'm flexible. I'm actually not working this week, so my schedule's open.
Okay.
Mine too.
Okay, let's try for Friday morning, if you're really that open.
Ooh.
Oh, you don't get out of bed, yeah.
Yeah.
Oh, I know your type, so you're like an 11 a.m. start probably.
Yeah, Mountain time.
Yeah, Mountain. Okay, so let's try for 11 a.m. Mountain on Friday.
Okay.
and I'll round up Michael. And if that's too late for him, then we'll have to try for Thursday, which maybe at this point we should just say Thursday. Well, yeah, Friday night. He's in Eastern Europe, so let's try for Thursday if you guys are indifferent.
I'm indifferent.
Okay, Thursday, 11 o'clock, Mountain.
As long as we keep to Steven's schedule, I'm good.
Jonathan, what part of this country are you in? I don't remember. I know
I'm in Dallas.
in Dallas. Okay.
Central.
So you're maybe the same time zone as Steven.
Possibly. If I really have to do earlier hours, I can.
I just tell people whenever they request 7 a.m. that they're going to get half of my attention, and
Yeah,
I'll be
I'm with
drinking
you.
coffee the whole time. So
I just sent an email to all of you asking if Michael to confirm. Once he confirms, and I'll make that meeting and we'll all show up.
Sweet.
And invite everybody else here.
yeah, and to avoid just adding on to the session too long, I'm going to stop talking about it now. But if anybody has questions or ideas or concerns or things, and we do have that P2 cube topic on the forum. I'm happy to take input as long as you're okay with my opinions as well. Any input's good input.
We appreciate your interest.
Yeah. Can you show your desktop one more time? Just want to grab
Yes.
a screen capture of that.
So good. And Jonathan, I've got all the parts here that we're speaking about. And so being able to visualize them as a single system and occupying as minimal space, as you're saying, is challenging.
Yes. And I really do think if we can fit it into a cuboid that's the same size as the original P2 proto board, the eval board, we should be good.
Yeah. And if we're in that space, you still have space for the battery?
Well, that's a good question. I do think that there's room. One last visual check here. So the battery is in there. If we can't put it flat up against any face, but we can push it up into this void between two things. I think we might want to leave about a 1-inch square edge,
Gotcha.
or just assume that we need to conserve on one side.
Okay.
To make room for the battery, that battery at least, and that pack seems to be a pretty standard format that I feel better about because it is packed in plastic and it's somewhat robust, and with a little bit of soldering, you can put a good XT60 connector on it. And
I think Ken had some barrel-shaped batteries as well. That multiples of could be an option, right?
if we have some, yeah, I mean,
Yeah, they're
anything to
just
fit the space.
18650s.
Well, focus doesn't work, guys. Sorry.
Yeah. I think this battery, Jonathan, is a LiPo, did you say, right?
Yeah, it's a LiPo. It's a 4600 milliamp hour 50C, 7.4 volt. It's 2 cells, I think. 34
Roy, I
watt
don't know
hours.
if our Li-ion batteries would do it. Those 18650s don't source enough current.
They make LiPo 18650s.
Oh.
Pretty sure.
Yeah, if anybody is a battery expert and has some good ideas, please post them on the forum too. I'm not opposed to getting more and trying them out.
Yeah, Tubular just confirmed yes, they do in chat.
Much easier to charge those, I assume, then in that form factor.
Yeah. Well,
yeah.
I mean, you can charge LiPos with any standard charger. I mean, as long as it's a balanced charger, if it's multiple cells.
Do you want to require people to buy a charger like this? I don't want to ask people to do that.
Oh, well, if you have the 18650s, you can charge them individually with much simpler circuitry because they don't need balanced charging. You just charge each cell by itself, essentially.
All right,
like a regular battery style form factor per cell.
Just yet another aspect of being a cube and powering yourself.
Parallax used to sell a board that could charge the lithium-ion version of those 18650s and then use them as a power source. I have a bunch of them.
Interesting.
Jonathan, the battery you're using, being a LiPo, does require a balanced charger, right?
Only if it's more than 1S, right?
The
If
one I
it's-
have is a 2-cell, so it has a
Yeah.
intermediate voltage probe built into the wiring. So yeah, it does require kind of a specialized charger. And if we had a single cell that could give us that wattage at 5 volts, I'd much rather do that, especially if we could use a basic charger. I mean, we haven't even talked about the desktop version of these things. Like this version we're talking about is fully self-contained, untethered kind of a thing. Any other version of powering this can just use a basic wall wart, like something that we put on a desk, a lampshade format, an info panel format. All that stuff is much easier than this. So this is the hardest version. I guess we could have stepped our way up to it, but I feel like having this done is going to be a good place to be, and then we can kind of refactor everything after that we want to.
Well, we like engineers that make releases, incremental releases. That's welcome here.
Yeah, me too. I'm working on it.
Yeah, it might be a good idea to just get the desktop one figured out, just because then you can get a lot of the software and powering details sorted with just a wall wart instead of a battery.
With the files out there for the 3D printing, anybody can print the frame and then assemble something that is ready to be plugged into the Hub 75 adapter. So there's plenty of room for experimentation there for that part. I'll keep plugging at the battery side, see if I can figure something out. But if it becomes a blocker, then we can mulligan and we can do the desktop version just to get something up there. But that does change the question then about whether or not we need the adapter PCB. So we can talk about that, I guess, on that meeting this week.
Think of Flat Sam. I'll have the full guts of this thing running, but laid out, not in cube shape, as soon as the panels come in. And so we'll have good power studies by that time. I've got not a highly accurate, but I've got a bench power supply, so I can tell you the amperage we're drawing and how we're limiting it and stuff like this. So,
Perfect. All right, I'll look for everybody else on the forums.
Then I probably have a 2 or 3 minute update on some driver stuff for the matrix panel, Ken, if you're interested.
We are.
I was having fun with decoding panel scans. I'll just share a single document here, if I can find it. Can everybody see that?
Yep.
All right, so I had a case where I fired up the 1/8 scan panel, and there was rumors that these were going to be, each row was going to be split across multiple rows, and some of the columns were going to be moved to different rows. And in order to figure that out, I happened to notice that my regular panel driver was actually driving the 1/8 scan. And so you see the columns left and right. Left was the test pattern I came up with, and right was the panel being driven with that pattern, which proved to me that the rows were not being split between columns. The second row then shows that I just did another test with all the rows being the same. And sure enough, the 1/8 scan panel with double driving shows all the columns beautifully. And you'd think I was good to go then, but the bottom left is, okay, but which rows appear where in the scan? And so I visually numbered them with decimal numbers in cyan, as you can see. And when they're in the proper order, they come out nicely as on the left. And what our 1/8 scan panels were doing was skewing the rows. And so I had to kind of remultiplex the rows to get a good 1/8 scan panel drive. And so as you write your color map to the panel, it gets stored in to the driver, it gets stored normally. But when I generate the PWM frames, I do the row swizzling. And so now the panel's working just fine. But I just thought that might be an interesting show how we can number, we have pixels to play with. We just number them and figure out which row showed up where to decode it.
I don't know if it was your camera or the LED panel, but there's a lot of green in the one in the middle picture.
Oh, yes. Yes.
Is it because the green is just more efficient?
I couldn't tell you. I just drive them without paying a lot of attention right now. And that's also the P4 panels. So they're a little bit larger. Each panel technology that I use seems to have different color representations, slightly different.
Yeah.
That panel does have configuration settings for color intensities and things, and I'm using the default values. So I can't tell you. That's a good question though.
There are
some. So Chip, it's a little deceptive because the green is flowing into the cyan and sea green is in the middle. So
Right.
your eyes are blending the greens more together.
Yep.
Yeah.
Yep.
Well, he's probably using that ramp where you take like 0 to 255 and divide it into 3. And so you ramp up, you have a peak, and then you ramp down, and you juxtapose these 3 so they're overlap, but someone is always at peak power. That's how you get that chroma pattern.
It's actually degrees too. It's actually the RGB color split across the 360 degrees, but yeah, somewhat similar. We're driving 2 colors at a time through Max across the 360 degrees.
Yeah, always 2 colors.
Right. And so that was just an easy way to get the rainbow effect.
Yeah, and one of the colors is always saturated, right?
They move from 0 to saturation. Right. In pairs. Right.
There's points where the colors are not all saturated. Like some of them are, like you'll have 2 that are not fully saturated, but on.
Correct. Yeah. So that's anyway, that's all driver characteristics, and I haven't done anything to tune or adjust pixel brightness or anything else based on panel technology. We may or may not have an ability to do that in the driver if we want to go to that much detail.
Yeah,
but anyway, I just wanted to let you see what we're on. Excuse me a minute, Jonathan, just to wrap. I just wanted to let you see some of the things I play with to try and figure out row mapping and how to visualize it so you don't have to count. I was using colors alone, and finally I said, no, just number the rows because we'll never figure this out. So simple enough. Anyway, you were asking, Jonathan?
I was just going to say some of the drivers, for example, some of the Adafruit drivers for the LCDs and things like that, they have calibration tables because of the intensity, the luminosity of some of the LEDs is known to be nonlinear.
Okay.
And I don't know if those come from the manufacturer or what, but I think for some of the panels, we might be able to find some of those tables in an open source drivers. We can borrow the tables if we want to try to dial that in at some point. But I don't think it's urgent by any measure for what we're doing now.
Right, and when I'm researching how to color control these things, there's a whole bunch of write-ups about human visualization of colors, of color space and color theory, and people who like to see things in different color spaces, and so there's a lot of research there that we can play with. Generally, what's in the driver right now was one of the screen techniques. I'm drawing a blank on the term, but it's the gamma correction. Certainly not needed for LED panels, but it is a way to currently spread the colors to a more usable set, a more distinguishable set from one another. So that's in there now. That will probably be removed as we get scientifically more accurate. And instead of doing a fixed width PWM, we'll do probably a logarithmic distance for light fall off, PWM instead. And so as we get better controlling brightness and stuff, that's where I expect the driver will go. And that would cause us to lose then the gamma correction and stuff like that. But it was quick and dirty to do and gave us reasonable colors, so it's in there right now.
One more topic for me, Ken and Chip. If you have any extra of those boards with the SPI RAM, I would like to be on the list for when you have.
All right, I'm going to make a note of that. Got it. Now, Ken stepped out for just a minute. The part number for the QSPI 8 megagram, hold on. There are a couple different manufacturers. I think we got some parts from Lion Tech. Oh, let me see here. Ken texted me this, so if I expand on. Okay, so anytime you need technology to work, it certainly won't.
Demo goods.
I've got lots of data here, but where's the part number? Is it not on the piece of paper?
How high res was your photo earlier? Well, I guess that was on Ken's desktop.
It's not that. It's just that it's not clear, but let's see. I don't remember these part numbers. They had like 5 numbers and a few letters in them. They had like something like two digits and letters and then 4 digits.
Are those chips expected to clock at like half clock speed, let's say 120 megahertz SPI?
Yeah, so they go to 134, I think, or 133 or 109 if you're running at 3.3 volts. Some of the chip, they're all slightly different, but they have the same protocol. Some of them run a little bit faster at 3.0 volts than they will at 3.3. So I think the 3.3 volt speed was like 109 versus 133 for 3.0. But that is their worst case. Just like you can overclock a P2 chip, that's considering they wound up with worst process conditions on their die, lowest voltage, and the temperature is 85 C. Okay. So you could probably run those things at 160 all day.
Yeah, I just need 120 to work.
Yeah, I think that'd be safe.
And just so you know why, I'm clocking at 240 for anything I'm doing to do sample alignment and simplify cycle counting.
So you'd need 240 to get 2 clock transitions to make a cycle.
And that'd be fine. I mean, for sample data, I think that's fine.
Yeah, that would work. I'll try to find a part number here.
I think Lachlan just dropped it in chat. Is that it?
Yes, that's it. The 68L 6400. Almost, yeah, SLIT, yes, funny part number. And there are a few other parts that we ordered, I think, or maybe we both got these, but there were a few parts that had basically the same specs and the exact same protocol. They're very easy to operate. You just gang the datas together, and then you have a group clock and a group chip select. And at that point, it's just like one SPI chip, but it's 16 bits wide. So when we give it commands, we're going to have to copy we're going to have to take the nibble, blow it up into a byte, and then cast it, to 2 bytes worth in the, or 4 nibble, no, 2 bytes worth into the IO pin frame. So it'll take a couple instructions to go from a nibble to all sets of 4 pins reflecting the same nibble. And we could even just use a lookup table,
How many pins to drive to interface total?
Well, because we have 4, it would take 6 pins, but because we have 4 sets of 4 datas, it's going to take 18. It's going to take 16 for the data, and then 2 for the chip select and clock. So 18 pins. So, on the top 8 pins, we have 56 and 57, which aren't really used for anything. So those are going to become, 56 is going to become, 56 is going to be clock, wait a minute, what is it? 56 and 57, because 58, 59, 60, 1, 2, 3. Yeah, so 56 is going to be clock, 57 is going to be chip select that goes to all 4 of those chips. And then the next 16 pins, which take 2 8-bit ports, but are not word aligned, right? If you took a long, this word is like right in the middle. Here would be like the high word, the low word. This is kind of straddling. So but the streamer actually uses byte offsets to pick off, 8, 16, or 32 bits. So we can slide the window for the streamer to hit that spot, even though with instructions, we have to do 2 byte operations because it's not word aligned on the port. But the streamer can get there with byte granularity.
I'm hoping you're going to give us a good example of the streamer once that carrier's out.
Yeah. Well, we're reliant on the streamer to make it work. I mean, to make it work quickly, But we'll just set up, the way it'll work is we'll feed it the command, the address, the read command, the write command. We'll set up the streamer mode and then make it smart pin do the clock transition. And then we'll just juxtapose the instructions that turn those things on. And then it just runs. And then we do a wait XFI for wait streamer finished. And then when it's done, it will have, transferred. We can do a K byte at a time, read or write. The page size for access is 1 K byte. So that means really 2 K bytes we could do because we've got.
Can you give an example of a service routine that lets us queue that up and then look for it to be completed after doing some other things?
Yes. Yeah. When I get that thing, probably next week, I'll be able to write it.
All right. Cool.
I could write it now, but I'd like to have the thing in front of me to verify that it's working right. But that'll give us a nice 32 megabyte thing. And we could actually, write individual. See, it's easier to use this thing. It looks kind of low tech compared to the HyperRAM, but because you can feed separate nibble, you have to feed it its commands nibble wise, right? Every chip receives a nibble and there are 4 of them. So you could put some in like a do nothing mode and put some into a write mode so that you could selectively write 1 byte. If that's what you really wanted to do, you didn't want to have to like cache a whole, 1K or 2K bytes and then put it back. You could actually write, because sometimes it really is important just to be able to write 1 byte. Like if you're adding to, well, I don't know, a random access would be important. But if you're just streaming data, it's more efficient to have your own local buffer. And then when that buffer fills up, then tell it to transfer it. A lot more economy in doing it that way.
My questions are back on the DSP processing realm. I mean, the cube is a side quest, right? This is just a stepping stone to, get some things under my belt and also contribute to the ecosystem so that I can go back to what I really want to do, which is the synth stuff. So streaming memory and coupling processes together with low latency and low wait times is going to be important for what I want to do.
Yeah, that's kind of a building block we need to be able to facilitate the fun stuff. Yes. Hey, Jim Goodpaster asked, in that sharing configuration, there's no possibility of using them individually. Well, the only thing common, remember, is the clock and chip select. So to the extent you can do different things with them as you hold all their CSs low and clock them, you could make them do different things. And he asked, what's the throughput? So if we're going like Jonathan wants at 120 megahertz, and we're getting data out, that means at 120 megahertz, we're getting 16 bits per, right? So we're going to go 120, it'd be 240 megabytes per second, right? And he says, wonder what the throughput is at say 80% reading and 20% writing at 2 times the chip's clock. Yeah, that's, 240, okay. Yeah, all these things are stuff, once we get them in place, then it's like wide open to do all kinds of new stuff. Ken's back.
Looking forward to playing with them.
What's that, Jim? Looking
forward to playing with them.
Yeah,
the RAM chips.
And one thing I forgot to mention that Jim and I have been, this stuff's all Jim's idea. I didn't know anything about how to make Space Invaders. I just made an 8080 emulator that uses Byte, but Jim knows how to spoof the whole thing and fake the in and out instructions and all that. But we were talking earlier today that, you know, if we have these little game cabinets that are set up with buttons and joysticks.
Your video's froze, I think.
Configurations, like
Yeah, we just
what's
lost
that?
You're back. Maybe.
I'm back. Okay. There,
Lost 10
if we make these game cabinets like Coley's designing, there's no need to always have them centrally controlled. You know, we could control a bunch over cables from a central P2, or you could just put a P2 edge socket into the cabinet and you know, do it that way. I mean, if you want to use like that 32 megabytes for some reason, and then have stuff not written in 8080 that they're making, but, you know, really in PASM or C or spin or whatever, then you could just make it all one.
Yeah, haven't you got Python as well?
Wait, say that again, Jim. Sorry, I didn't hear you.
So, I'm sure Coley said someone had Python working.
Mm-hmm.
You muted, Coley.
Yeah, sorry, Jim. It was it's Team Oz that were doing MicroPython, and we were talking before about maybe what we could do is make this sort of an educational format and to program games in MicroPython, but to do all the drivers and everything for sprites and everything else. And then the best way to play it is on a little arcade cabinet. So, you know, I will do various iterations of the design so that we can have more buttons in and everything else, because I think I can get them all laid out onto one panel and just do, you know, and just wire up your multiple button inserts then. So there's lots of possibilities.
Yeah, that would hit the educational sweet spot pretty well. Ken, what do you think about the viability of having teachers have like a game programming class? I bet the kids would like that.
Games are robots.
Yep.
Yeah, it's true. So Lachlan, it's you've been to the work on MicroPython, haven't you?
Lachlan, are you there?
Sorry, just here, just connected on the headset. Yeah, yes, we've got MicroPython up and running nicely with a P2, and we've got 7 other cogs which we can do what we want with. And at the moment, we're using 2 of them, one for VGA driver and the other one for a USB keyboard. And so that's all up and running, and you can download the MicroPython from the Parallax site and have a play. But one thing I was going to say, Baggers, one thing we can do, or we could demonstrate, because the 8080 emulator is a pretty tight footprint, like not a lot of code, we could actually just spawn it from MicroPython. Like we could just take that binary emulator and point it to, and point it to 64K. And I think that kind of combination of having retro, something to entice you from the past, combined with, you know, the up-to-date programming language is kind of a key kind of bridge, you know, bridging the old world and the new. So
yeah, that would be neat. I mean, that would be something for a teacher to demonstrate to the class. Is like, here's something that you could do that has like high impact.
Yeah, and multi-generational. You know, you got the teachers who remember Space Invaders, and you got the kids who can program Python. So yeah.
Now with this platform, since effectively your consoles are centrally connected, it sounds like there's an opportunity for something ultimately multiplayer as well.
Oh yeah.
Yeah, we've talked about.
Sounds like there's an opportunity for some sort of gaming multiplayer framework to be developed around that hardware system as well. So not just doing assets as development and Python to drive, MicroPython.
I think like a multi-headed gaming console that lets people learn to write games for multiplayer is way more compelling than just a miniature, right?
Yeah.
The interactivity, the party games, there's just a whole spectrum of games out there that suddenly become interesting to people that you can't do for single player.
Yeah, what fuels the whole robotics curriculum is when you get little competitive things going in the classroom. Like, okay, who can get through this? Who can go, you know, this far, turn left and go that far and turn right and make it out the other end of this little maze or something. Kids love that.
They
They're
would
like
love it.
quickly
Yeah,
going back
we're all
frantically.
playing against each other.
Oh, they love that. People love stuff like that because it's people are ultimately way more interesting than machines. So if you can make the machines a point of like people competition, they love it.
Yep, that's a good plan.
I almost want to build a multi-headed arcade cabinet now just to be able to play with that. I got too many projects already.
Well, don't worry about it. We'll get Ken to sort them.
There you go.
Yeah, maybe we could stock those things if Coley comes up with a recipe for the laser thing. And
Yeah, he's already done it.
Yeah. I mean, if it was just something to download, we could supply them, or other people could. But
yeah, it's just I just need to do a few tweaks to the design, and just do some options on joysticks. I think the joystick I've got is probably a bit too big, if I'm being honest. So I just need to source some of them. But me and Jim have got a friend in the UK, Craig Turner, who does retro arcade machines. So we think he'll be able to source us a better joystick, and he's offered to do some marquee graphics for us as well. One of the questions I was going to ask was, could it be nice to just put the P2 logo on the side? Do you have the artwork done for that? Is it readily accessible? Right. Where can I find that?
What do you want again?
The P2 logo.
The P2 logo.
He wants to give you some free press.
Yeah.
Okay. Well, Ken, are you?
Oh, we're going to get them some good press.
Oh yeah, we're going to get some really
for it
good
right
press,
now.
See, we used to have a graphic designer, but she's gone. So I think Ken is the graphic designer now. He knows where everything is.
Okie doke.
That's an overstatement.
Yeah, if we can just get the source files and like I say, Craig's offered to do some fancy graphics for the sides of these cabinets. I think what we'll do for the demonstration that we're going to do, we'll even have vinyl on the side of them, so they'll look a bit snazzy as well. But you know, we're just discussing it's 3mm MDF we're opting for, but it could as easily be plywood or even acrylic.
Yeah, 3mm acrylic. Hey, Colby, have you looked at, you can buy coin slots, like all-in-one coin counter kind of things? I'm just wondering, could that fit in the bottom or the side or something like that? Or
there's certainly enough room for it to fit in the side.
Yeah, like down low at the side maybe or something, because then you can turn it into a gold coin donation or whatever, or 20-cent donation, I guess it would be. But thinking to like trade for
Bitcoins.
I was thinking
terribly expensive.
On the acrylic,
go ahead.
On the acrylic designs, in my experiments, I found that actually gluing things up with acrylic glue is possible, but it's very tedious. So anything that's the tongue and groove or slotted is going to be better for the general audience. It's just easier.
And your metric hardware works very nicely in the acrylics as well.
Yeah,
easy for metric screws to assemble stuff.
This design is tongue and groove effectively, so but there is some gluing involved because it's MDF. But eventually you'll see I don't know if you can see from but there's the outer skin is a little bit thicker because it's two pieces. So it means that on the side
you hide the T and G.
Yes.
Yeah.
Hide
Yeah,
the T and
MDF
G.
is accessible to everybody, and anybody can go get MDF and Jigsaw. So.
Yeah.
Yep. That was the purpose behind it.
It's easily done.
Yep.
Kind of embarrassed to say, but I think the P2 logo was actually developed by the community, and we don't have any original artwork. I think we scraped it off of a forum post to put it on the chip.
Yeah.
To be honest,
there was a forum post where it was being pitched about, Yeah, I remember reading that. So that's it then.
I found the link.
I think Peter Jakaki did it. I'll ask him.
Yeah.
What was that, Ray?
I think Peter Jakaki did the logo. I'll ask him.
Thank you. Appreciate that.
Yeah, and if he can't produce, I'll paste in the chat the closest thing to it, okay? Here it is.
Brilliant.
See, there's something happy about a coin op because it's just this nice quaint anonymity. You throw a coin in and it works. I was thinking about what if you put like some biometric ID on there, but that's not fun. But I was remembering this friend we have up here in Red Bluff who works at this place called Sierra Pacific. He said they now have they bring in logs that have been cut, and they cut them into boards, and as the machine is approaching, as it comes down the conveyor and it's approaching this saw that's all spun up, they have to make a decision in a half second based on today's market prices for different cuts of wood, how they're going to cut this lumber. And so they've got the decision time down to a half second of transit for the log. Then it flies in the machine and it cuts it all up. But he said that they're doing something now where they have like a CT scanner, kind of like a medical, but the log goes through the CT scanner and the computer remembers that log and every piece that gets cut out. So there's no need to do serial numbering on any parts. You can take any piece of wood that came out of the factory, rescan it, and it will know what tree, what day it came out of. Everything, it's like, because everything is unique enough that it's its own fingerprint.
A little scary.
Yeah. Yep.
I want to change the subject for a second before I leave here. On the RTC that we had going here a few weeks back, I put the I've got a watch battery in it, so and the time remains through reset and turn power off, and I can put the calendar date in, and it will stay there. But as soon as I reset the board or turn power off, it doesn't come back. Is that something anybody else is seeing? Ken, does yours keep the date that on the quick byte that I used to straight code from the quick byte and put the date in? Does your date remain through a power off?
I haven't tried the same test you're talking about. Are you sure you aren't overriding the time when you?
I've successfully had it save the time through a power cycle. You have to have the battery in, obviously, and make sure it's a good battery, but it worked fine for me.
Yeah, the time saves fine. The time on it works pristine, but the date is only in there if I put the date in, and the current date will show on the PST. But as soon as I power it down, the only thing that comes back is the time. The calendar zeroes out.
No, I can't verify that right now, but I can test it later.
No biggie. I'm gonna get a couple more of them, but I just wanted to know if anybody, if that was a common thing that the date had to be put in. All right, y'all have a good night.
You too, Brian.
Bye, Brian.
Chip, since no one else is chatting, got some questions with send and receive.
Oh yeah, okay, and spin too. Okay, got it.
Yeah. I think I'm right in the fact that I can't use it with what I'm trying to do. Do you believe that's right, or do I need to re-explain it?
You better re-explain it to me. I read your thing, but I don't know, I processed it and then it popped off my stack and I started thinking about something else.
Fair enough. I have a version of Johnny Mac's formatting for duplex serial, but my output outputs it to a buffer in hub always. And you can call multiple objects, that's fine. But what I'm trying to do is that I can have sitting off the back of that hub buffer, buffers, plural, because there's one for every pin, or one for every serial transmitter, one for every serial receiver. You can have multiple serial transmitters and multiple receivers. I've just completed my LCD display that hangs off it. So the top end code doesn't know what's sitting at the bottom end. And so I want to be able to substitute that driver in another cog that might go out to an LCD, might go out to a VGA, might go out to a serial port, might go out to one of a number of serial ports. And so I might want to, in my top level code, output to a number of those in parallel. So for instance, I would say, call Johnny Maxwell, my object, SER1, SER2, and so forth. And that's when I think all of a sudden send doesn't help me, does it?
Well,
because
okay.
otherwise I have to substitute it every time I want to go serial 1, output this string, serial 2, output this string. I'd have to change.
You've got to make a cut somewhere. What you could do is have send point to a thing that sends out to each of the 4 you want to send to, right? So that all your sends, they aggregate, you get to use the send syntax, which can save a lot of space. And then send calls a routine that then sends the individual data out using method pointers or whatever, or directly to your destinations.
But is send, okay. But in my demo program I've got here with my LCD, I send a set of strings out to the serial terminal and then a set of strings out to the LCD. Then I go down and I just send some to the LCD, and then I decide to send some to the screen. I don't want to be changing the pointers all the time. I just put SER1 or LCD dot and whatever instruction I want. Am I right in saying that send is not going to help me, is it?
Well, okay, so you want to use send because of its syntax, but you also want...
I can't see it's helping me with the syntax, because I'm doing a transmit character, I'm doing a format string, I'm sending a numeric or whatever. Well, there's all these methods to do that.
Okay, so send doesn't really help you with that.
No.
Okay.
I just wanted to confirm that I really am right, because a few people have come back and said, no, you should be using send. And I really can't see that it can help you. It's only confusing the issue.
No, I mean, the value, send has 2 things that are important. It has some kind of like efficient syntax, and it actually makes efficient code too. If you want to mix strings and values, and as you call down, it gets conveyed to every callee, right? And so on. So once you set it up, everybody down the line will get the same method pointer. So if that's not what you need, then you might as well have separate method pointers for anyone that you might want to talk to, and then maybe have some flags saying when to send. You either call those method pointers at any point you're generating the data, or aggregate them somewhere and have some flags that will say, at this point, I want this message to go to these 3 concurrent places, but not this 4th one, and then have it.
Yeah, I see that at the top level, I just decide which ones I want, and I just repeat the call.
Yeah.
And it's not doing, there's really very little overhead in it, because it's still going to use the same string. It's so it's not defining 2 sets of string values. have you seen Johnny Mac's F string 1 where he picks up parameters?
I don't think I have. I haven't.
Okay, I can't see that it works with that. He's got a command that will format a string with a variable, so you can set a variable in the middle of it, like you can do with Pascal and C and Python and everything else. They've all got their own variations of filling strings with variables in the middle of them. And he's just developed one along the same lines, and it's simple and easy. But I can't see that send allows you to encompass that anyway.
Yeah, for what you're doing, it might be more, I mean, you're not, it's not, you can't really exploit it like it's meant to be. It's meant to be for kind of a case where you just want to send like everything out some direction and you want everybody to inherit the pointer without having to explicitly convey it. And
yeah,
it helps with stuff like that.
Yeah.
But for what you're doing, I mean, yeah, if you've got like a 16-way serial, you know, transceiver, then it might present more trouble than it's worth.
that's what I thought. I just wanted to confirm it because of
Yeah.
your comments.
Yeah, all the talk about it.
Jim Goodpaster asked if let's see, regarding method pointers, I used a 4-element array of method pointers, say, and it seemed to work fine, but can you use an array with the send pointer? Yeah, why not? Now the send, you can't put an array after. You can't put send and then in brackets a value, but send could call something which would dispatch to like a set of method pointers, you know, and you could index them and direct things out that way. But send itself is not indexable because it's just one instance. And see, it's this little thing I put in there because it economizes this case where you just want to send, like you've got something that might format some decimal string for you and you want to send it somewhere else. It's nice to use for something like that. But if you've got multiple sources and multiple destinations, it doesn't really provide the benefit.
Yeah.
Yeah, you know, when I think I said this here once, not to bore anybody, but back in 1991, I got Turbo Pascal and it was object oriented. They had these books and I was reading these books about inheritance and polymorphism. And I'm going, man, how am I going to write an assembler that uses all this stuff? And it was killing me trying to figure this out. And the thing is, what was really just an option for the programmer to use was presented as the only way to do anything. And I was like, having to think in such a different way, I just couldn't figure out. And I felt like I must be just not getting it. And I just must be stuck in my old ways. But really, you couldn't exploit that stuff to do what I wanted to do. It doesn't work that way. It's like, you know, Ray using send to do 16 different directions. It doesn't work. So yeah, well, there's a lot of stuff like that. We get to thinking that, you know, thoughts and notions are prescribed that take a long time to like get over and realize I didn't need to think that. It was just a suggestion, but it's set up like concrete in my head and it was not important.
I've got a data structures book from the late 80s when I was in college on Pascal, and it will make your head explode.
How so?
It's just the way they did that stuff, just like you were saying, the way they did that stuff in Turbo Pascal was just kind of, by today's standards, is kind of way out there.
Yeah. It's like it's like your old programming ideas didn't seem relevant the way they talked about how things were to be done now. And you had to adopt new think. And it's like, how can I make an assembler in new think? I just can't picture it. And so I felt like it would be a dirty thing to go back and do it the way I know how, because that's just what seemed to work. But, you know, I was right. I just bamboozled by this over prescription of objects.
Yep.
Oh, so things have turned. Some are saying polymorphism is dead or not really the answer. Yeah, maybe not. I never did quite get it. So,
like any application of a tool, it's got its places. And there are regions of the software engineering science where it can actually benefit. Not everywhere. Just flat out not everywhere. It's not going to work.
yeah.
But for aiding in decomposition of larger scale problems and trying to match code to what you're trying to do in a larger scale, yeah, maybe it works pretty well there.
But by today's standards, wouldn't like extending a class kind of be the same thing?
Big long discussion, but no.
So I use polymorphism like all the time in our work code. We have a huge giant project and we would not live without it.
Correct.
Like thousands and thousands of files, millions and millions of lines of code, lots of people all working on it simultaneously with giant systems that, you know, one system is bigger than you could fit in a P2. So
I could, Roy, I could take that to a smaller scale for, let's say 7,000 gigabit samples per second being captured simultaneously logic analyzer, that we couldn't do that with that software without it as well. Millions and millions of lines of code and multiple acquisition cards feeding into one system of all different rates and speeds. You just can't do it.
Yeah, and on a related note, that's why I use and love debuggers and want a stepping debugger ASAP chip. I know you don't care.
No,
You use printf and LEDs, but a real proper stepping debugger matters a whole lot.
I agree.
You didn't agree years ago when I tried to convince you to do it on the P1.
Yeah, no, I know. I've been fighting to get back to it. I've just been on some other stuff. Huh, yes, Jim said that if we put send and brackets after it, it compiles but doesn't work. I don't know why the compiler, I need to figure out why the compiler's even pass. I don't know what it's doing with that, but that doesn't make any sense.
How to pass by your compiler engine.
I mean, maybe what I do is I go, you know what I think it is send is actually a register. So I'm saying we're going to use a register variable as a method pointer. And then when it later sees an index, it just, okay, we'll go to the next register after send. And the next one.
Yeah,
that's why it's doing that.
You need to add a little check into the compiler parser there.
Yeah.
Yeah.
Yep, one more.
Yeah, because you can. What's that?
Well, I said yet one more sensical syntax check.
Yeah, but you can do like variable brackets and then parentheses and things, and it will use that as a method pointer, right? Pretty sure that's what it does. So it's just saying send. Hey, Stephen, this super duper wide logic analyzer, can you say what it was used for? Or is it all?
Think of big names like Intel.
Yeah.
Trying to monitor all the pins of everything they do. This was a rack. This was a rack of equipment, all time-based gang together, where where each element of the rack was $100,000 or multi-$100,000 logic analyzer.
Right.
With 7 cards of acquisition channels at 64 channels per card, that kind of stuff.
So you had to aggregate all that data.
Live and time correlated live and yeah. And so every analyzer had its own application running and amazing time correlation between the different boxes. Also.
Man, I would think that just hooking in all those wires, because these were obviously.
Yeah, you have no room.
Yeah, and the loading of the wires must introduce their own issues.
Well, HP and Agilent were kind of leaders in low loading.
Like FET probes and things.
Oh yeah, we worked with the processor manufacturers to
Yeah.
design the attachment mechanisms. And so, yeah, it was stunning. Where you'd pay thousands and thousands of dollars just for a single
Yes.
ribbon cables and connectors, and it was Kevlar jacketing on the wires, and all sorts of stuff.
Everything's impedance controlled, and yeah, I don't. Let's see if I can. I'll show something. Let me grab something here.
You've got one of the older instruments there, don't you?
What's that?
I'll watch. I'll wait and watch.
Oh man. Whew. Everything
Yeah.
is dusty here. So
Every time I
this-
pull out a different piece of gear on my bench, right?
I have I think it's a 1.5 gig scope. And this is an active FET probe. This is an Agilent thing. And so see, instead of just the regular, what do you call it, BNC?
Right.
The round, this has many pins. And what it has in this tip, which is a little bent, is a FET gate right in there, which is only a couple picofarad.
Correct.
And then so
endpoint loading, yeah.
Yeah, and this thing gets hot. I mean, there's a lot of current flowing through here.
It's
This
amazing.
this is probably 15 years old. This 20 years old maybe. In fact, maybe I think it has like Windows 1997 it comes up with.
Oh yeah, yeah. I used to build all those Windows systems for the logic analyzer family, not for the scopes, but for the logic analyzer family.
Now it says 0.6 picofarad. I don't know if you can see that, but
Can't see
this
it.
is extremely low loading, and it can capture really fast signals. So it amplifies that and then sends a very low impedance, high speed signal down this cable, which then goes into the scope on this crazy multi-pin thing here.
The scope and the
Anyway.
logic analyzer team sat side by side in the same building.
Wait, say that again?
The scope teams, while they were 3 and 4 models of scopes being worked on at the same time, and logic analyzers, same thing. Those two major teams sat side by side in the same building. And so the problems those teams were working on were just fascinating. And we'd give ourselves kind of, the R&D lab would meet and the teams would talk about the latest frontier of what they're working on. And we'd keep blowing each other away constantly at what they were trying to do with signals and signal measurements and, stuff like that. Just fun.
Yeah, there's a lot of ingenuity that goes into that kind of stuff.
Can I interrupt you guys for a moment?
Yep.
Please.
Okay. Yeah, so Francesco, who is in Italy, has made a PC board design with the P2 edge, and he'd like to share it, but where he lives is a high density area, so he's afraid to wake up the whole neighborhood.
No.
so I'll share what he's got. He sent it over by email, and then next week maybe we can look at this a little more.
That'd be fun.
So I'm on a laptop. I don't know if this is sharing properly or not. Or if it's okay, it's not showing all the Zoom junk as well then, right?
That's not.
Okay, good. Yeah, so he summarized the board. Let's just give this a quick read together, then we'll look at it. So it looks like a super nice design. So he's been doing consulting work with the P1 and the P2, and to save time, he came up with the idea of developing a hardware modular platform for professional and industrial use. He calls it the P2 Platinum Platform, or also P3, Propeller Platinum Platform, P3. Cool. So the platform uses the P2 Edge, has some basic peripherals on board, an RTC, Ethernet, and Wi-Fi module, micro USB card, 2 USB hosts, 1 USB slave, and the platform has 5 slots, which he has called smart slots, 4 for general purpose and 1 for AV. And the 4 general purpose slots are wired like this: SO P0 to P7, S1 8 to 15, S2 16 to 23, S3 24 to 31. And the 4 slots have in common pins P32, P39. Wow, 24 volt power supply. It's nice to see. Plus or minus 15 volts, 5 volts, 3.3 volts, and a smart audio video slot. This slot provides for video, audio to choose between HDMI, VGA, with audio out left and right, audio input mono, and FTDI EVE2 HDMI display. Wow, touchscreen. So he's got almost everything in here, it looks like. Furthermore, S0 to S3 slots, you can put in cards dedicated for customer or system equipment under development, like conditioning and protection of components for ADC and DAC channels, isolated ADC and DAC, stepper motors, driver for small brushless motors, relays, triacs, and some power stuff. Okay, and he's going to install a Hammond die-cast box. So let's get a look at this. He's been busy.
Jeez.
Wow.
No wonder he'd be so excited. He would wake up half of Italy talking about this probably. So I don't know if you can correlate everything I read to what you're looking at now, but it looks like these slots are the accessory peripherals that are application specific. P2 edge in the middle. And up in the upper left-hand corner must be, what is that, do you think?
I'm guessing ether by the shape of it.
Ethernet.
Either USB or Ethernet.
Pair of USB ports.
And
That Wi-Fi in it, right? So
here it is in the enclosure.
USB.
Wow.
Interesting.
A lot of voltage regulators on there. Wow.
What do you guys think of that?
Cool.
I wonder if he's going to make it generally available to others too. He must be a very busy consultant then.
Yeah, it looks pretty good.
Super cool, Francesco. And keep sharing, and we're welcome to help you along too and share your work here, especially if it's late at night. I think he's jumped in a few times in the past and said some things. So that was it. Chip, I have to step out. Move on to the next thing. Unlike all of you guys, I start at 5 a.m. and I'm done at 2 p.m. So carry on. Thank you. This is very interesting. I've taken away some great notes from today.
Okay.
Okay, Chip, I've given you host, so yeah, nothing should drop when I step out.
Okay.
Thank you.
Okay.
Bye-bye.